So, welcome to this lecture in software testing. In this lecture we're going to talk about system testing. I looked over this lecture and the next week's lecture, and I sort of could not really decide which one I wanted to start with. But on the train on the way to Växjö, I decided to start on the planning of things, because it's probably what you want to do when you start the assignment 2, because it contains planning. So first, before I go too far, I just want to check if the online students who are following me can hear my voice and if everything sounds okay. Great. So we have a slight problem, that is the screen casting does not really work, so I have focused the camera on the projector screen here. But we will see how that works, and you have to live with it, really. Okay, so system testing and planning a testing activity. Sort of what you're supposed to do in assignment 2. And assignment 2 is a scenario where you get a piece of legacy software. It's just given in source code, so you need to start from the source code. And you have some requirements, and you have a scenario. And the idea is that you're supposed to test this software to see if it fulfills the requirement of the scenario, really. But there are also requirements given for this software, so you can read those requirements and see if the software given fulfills those requirements, or if it doesn't. Because that's going to be important to fulfill the scenario or not. You need to work on this assignment, and you need to plan your work. So this lecture is going to be about that test plan and how to do some of those things. And this plan and the different artifacts that you're creating for this, perhaps the manual test cases or the exploratory testing report or the test results from your automated unit tests. You don't need to write automated unit tests, but I can assure you there are some automated unit tests that you can run. And perhaps the coverage report of those and the things that we talked about last lecture, where you learn how to assess a test effort. Those things you need to communicate. So you're writing all your efforts in a document, and it's sort of the test plan. And you need to focus on clarity, communication, and traceability. So clarity is, it's the same as communication. Another student who reads this document is going to understand what you did, why you did it, and also believe that you actually did it. They have done testing of the same software themselves, so perhaps they have also run the automated unit test suite and come up with some kind of answer for that. So yeah, and traceability is also important. I mean, if you get a test result that is a failure, then we want to know which requirement is failing and stuff like that. Yeah. So it's a lot about communication, and a good idea would be to read in a format that everyone can understand, and that means English. Okay. So let's start with the strategy. So in order to reach some kind of goal, if we have a scenario, in your case in assignment 2 you get a scenario, we need to come up with a test strategy. And to do that, we need to define some kind of goals. And we also need to see how can we, with the given resources, reach those goals. So I think the assignment itself does specify some of the means that you have. Other things, it's up to you. Let's take an example from the requirements of assignment 2's software. it says that it's supposed to work in this and this operating system. And perhaps you only have one computer with one operating system. So that is sort of a restriction of what you can do. And that should be clearly a restriction, so perhaps we're not going to try all these other platforms because we cannot do it, because we don't have the equipment for it. And that is okay. And perhaps the number of students that does this assignment times the number of hours they have available is another restriction, right? So it's another means that restricts this. So the strategy is really a small story about how do we reach our testing goals with our means. For instance, a testing goal could be that we want to see if all requirements as stated are fulfilled by the software. A strategic means of doing this pretty, so if that is what we want, and then we look at how much time do we have, and then we come up with some kind of strategy to do this. So perhaps we're doing exploratory testing. Perhaps we're just going to dive in and see how this application works and see if it fulfills some of the requirements, and just let the exploratory tester spend so and so many hours on doing that, and they should note something. Perhaps we should have another strategy. Perhaps we should do the automation strategy. So, okay, we have a bit more hours perhaps in our group since we are 3 of us or something like that, and we really want to learn automation, so let's focus on automation here. If we're gonna, on a later stage in this project, gonna use this software and develop this software further, perhaps we also want to get some automated test suite so that we can continue that work and use that automated test suite for regression testing again and again and again. Yeah. Okay. This is also important. Stakeholders. The stakeholders are the ones that have some kind of interest in what you're doing. It's probably the company that you work for that are stakeholders here. It could be other people, it could be their customers also. And what are their testing goals? So it could be that that we have a stakeholder as a bank also, and other people who have different requirements that they think is the most important one. So let's say that the web server that you're supposed to test, web server software that you're given, the legacy code is for a web server, and that this server is going to run a web shop, and the web shop owner wants the full process of shopping tested every day. If that is what they want, and they want to know if this is something that we could do within this software that you're testing, then perhaps, since they want that every day, then perhaps automation is something that we need to do. Perhaps we should use a lot of tools for testing this application and see if this application or this web server works with like tools for automating web shops like JMeter and stuff like that. And an important thing is to think who are the stakeholders for this. And it's not that complex in your assignment. You just read the sort of specification for the task and think about, okay, who wants what? And there probably are gaps in my description of the assignment. You could either ask questions to me or just fill in the gaps yourself. But since other students are going to read your test plan, then you need to communicate where you fill in the gaps. It's totally okay to fill in the gaps, to say that, okay, we really need security testing here because this is going to be used in a security essential whatever. And therefore, we are going to focus on that in our group. But really, you do focus on that because it's fun and not because you have this customer, because it's just a made-up assignment. So you can form the assignment somewhat and fill in the gaps yourself, but you need to communicate to the students who are going to read your test plan, so they understand why you're doing this, and they understand why this is most important, and they understand why you focus on this. Okay. Then we have the means part. So I want you to, like, when you're planning, you specify these are the resources that we have, and it's sort of, okay, we have the people, and that is you, right? And then you have this time, and then you have different equipment. Perhaps you have other things that you can use for this. I don't know. You specify the resources. I would like you to, instead of giving the names of the students, I would say that you give each other roles instead. So you have tester number 1, tester number 2, test lead, whatever. Because I want these test plans that you're writing anonymous. And that is important because the process of examinations of this includes you doing peer review of other students' test reports. So you're going to read a couple of reports, and then you're going to write a review of those reports. And I don't want people to start fist fighting with each other after this assignment. I want this to be a pretty anonymous process. And this has worked pretty well the previous year. I was not here last year, but the year before it went very well. There were a lot of concern about some students that other students are going to read their work and like put grades on it, but you're really just putting scores on things. And then after that process, me and the team of tutor instructors are going to do a huge job checking all these scores, who has scored one bad test plan very good, and who has scored a good test plan very bad. And we're going to look at a huge matrix of these things. And we're also going to look at, is there a test plan that did not get any good quality reviews at all? Perhaps we need to give these students some feedback, right? And it's a huge process. It's not super quick, and it's not super perfect, but it's pretty okay. And at least in 2016, most of the students felt it was okay afterwards. But there was some concern that some other students going to read my work and put low grade on it for some reason, perhaps not really reading. Okay, so here's an example of a strategy. So the strategy was how to reach the goals with our means. And I've just written, since the application is relatively stable and deployed, we want to test the shopping requirements in use case 2 using fully automated system tests. These should run nightly to ensure availability and uptime. This running nightly perhaps is not really automated. Perhaps you're doing that yourself, whatever. And we're sort of imagining that you're doing one part of a bigger project. So you can divide this effort into different iterations. Perhaps now in the beginning, you need to get accustomed to the software itself, get it up, get it up and running, and things like that. So you can have a strategy part for different iterations of this. And you can also motivate to put some kind of testing to a later stage that does not include in this assignment. So perhaps some other students are not that keen on learning test automation, so they put that in the future. Okay, so the example of that is in this iteration, we focus on the ad system API since the developers released a new version. But also regression tests on the login system that was updated. So this was not really from assignment 2, but yeah. Okay. Now that we have a strategy, we need to decide what should be tested, which requirements are we going to focus on, and you get a couple of use cases and a supplementary specification telling you some different lists of requirements and stuff like that. And preferably most of those requirements are tested in some way. But I think the plan should state which requirements are we focusing on. And sort of, yeah. So it could be functional or non-functional requirements. It could be both static and dynamic qualities. Dynamic qualities was things that when we run the application, we can find out about them. And static qualities are things like we can look at the source code, or we can look at other artifacts and we find out information about those things. Like, is there a documentation for this project? That can be looked up statically. We don't need to start the application to find that out, unless the documentation is running documentation. Okay, I got a question. How big a difference does this assignment do in the end of actually passing this course? I think this should be stated somewhere on the course home page. I don't have that information in my head, but there is a percentage of the end score that is from this assignment. Okay, so I think the what of the test plan should also tell us if there is any part of the system that is more important than another part. And perhaps we're prioritizing our effort to the more important part, or you're prioritizing something that was recently developed. Now, in assignment 2, you don't develop the entire software, but if we are working in an agile project and we have these iteration after iteration, something that is newly written perhaps should have more testing, the iteration after it was developed, and later, if we don't touch that code, perhaps we don't test that as often, right? If we do a change to a piece of code, then we want to test that again, regression test that again. And that is the last part. What should be regressed? So what did fail last iteration, and what code components has been updated? And I would, in assignment 2, you could do this sort of, but really, you don't need to regression test since you're not really doing any development. You're sort of regression testing something that I tested when I wrote this software years ago, right? So in your case, you look at the requirements, see, okay, what are the most important requirements for this scenario that you're in, and then you prioritize from that. So we're going to talk about traceability later. And this, if you're going to tell what we're going to test, then perhaps you're also going to tell what are not supposed to be tested this iteration. And motivate that perhaps. So clearly describe the requirements and test suite that we do not test during the iteration and why. Perhaps we do not do manual testing this iteration, or we do not do other things. Okay, so now that we know what we're going to test, we also need to find out how we're going to test that. At what test level? Perhaps we're doing unit testing. In assignment 2, there are unit tests written for this software. So I would suggest running those on the software and see what you find out. Perhaps you can find bugs already there by just running those. Yeah, you could also integration test this with something else. Like we've talked about web shops and stuff like that. You're not supposed to write a web shop in this assignment. It's enough to test just the web server. But if this was another, not just a school assignment, and you were supposed to do something, perhaps there were other softwares that you integrate and you test these things together. I think in the application it contains a web server and at least one web client. And these things could be considered two modules that we integration test. Yeah, manual test, we're going to talk a little bit about that soon. And I think I'm not super read the assignment 2 for today, but I think that you're supposed to write manual test cases for assignment 2, but I'm not super certain about what the assignment specification says about that. But it's a good idea to write manual test cases. And so you decide which requirements am I going to cover with manual test cases, how much effort am I going to spend on that. Acceptance test is the tests that the one who ordered the testing or the software is going to do to accept your product. So if we have a customer for our software and they have ordered something of us, they've given us the requirements, they want to do acceptance testing to make sure that the thing that we deliver is what they order, right? In assignment 2, this you really on your own, so you don't really have the customer. We have an imaginary customer, as is the company that employs you to do this task, right? Yeah. Okay, more. What technology should we use? So should we focus on automation or manual testing, exploratory testing? Should we release this software to its end customers and let them beta test this software? How much should we involve the customer in this? In your case, you are the testers. You could like assign one person in the group to be the customer, but really it's all about choosing technologies for automation or doing manual things. Yeah. Also, you need to have some kind of measure on what is okay or not. And this depends on the scenario. You need to come up with some kind of conclusion, at least the grounds for the conclusion. So if we conduct all the testing that we now plan for, and we get results from all this, so I created a manual test case for scenario this and that, what happens if that's a failure? Is the entire project something that we need to scrap? Or can we fix this problem? Or what will happen? So this part is about that. What action should happen if something is not okay? And I mean, this depends on the stakeholders' goals, right? I would like to see in your test report some kind of statement that says that given the test result that we got here, we recommend that this software is used for this scenario or is not used for this scenario. But this is sort of how do we intend to use the information that we gain by testing. So it could be stakeholders. So perhaps we have programmers as a stakeholder, and they're going to continue the development of this software. And perhaps they want high unit test coverage. So if we ask the programmers, you're really asking yourself because you are filling in the gaps, right? And they say that, okay, it's okay, their unit test effort is okay, it's adequate if they have 85% test coverage. Then we say that, okay, this is something that we can continue on, but we don't want to retrofit this software with more unit tests unless we have that to start with. If we find out that the unit test coverage is too low, perhaps we do something about that. Perhaps we acknowledge the lead of low coverage, or we just write that as part of our report, that if it has lower than that, then we are not going to accept this product, then we should look for another web server. I mean, it all depends on the stakeholder goals, and it depends on what we intend to do in the next iteration. So if things are looking really bad, perhaps we need to spend the next iteration on doing something else. Perhaps we need to fix all these problems instead of continuing the development of the project. Yeah. So the example here is that, I mean, the customer wants all main success scenarios to succeed in this iteration. And if they don't succeed, then the action that leads to is that we're going to focus on the main success scenario during the next iteration because we didn't get it to work, this one. Okay. This slide, I would say, is important. And the reason for that is that most plans that I see students write is not plans. They're not really guiding the student's effort. It's something that the student created afterwards. Or, yeah, or meanwhile, I don't know. It's a plan, it should guide your work effort. And therefore, you need to not only specify all the things that you're going to do and how long they're going to take and stuff like that. You also need to say who is responsible for this task. So if you're going to plan something, you need to assign some means to someone to do something, and you also need to assign someone who is responsible for this. So by Thursday, Daniel should have done this and that. And his means could be that he has these tutor instructors that he can assign. So when you decide who's going to implement a test or so, you also tell who is responsible for that, and perhaps also when it's going to be done. Things that you need to think about is who has all the vital information to do this. One of the worst things that I know of is when you get an assignment and you don't have the means to do them. You lack perhaps information to do those, and you don't have I need to go to you perhaps to get the information in order to do my assignment. But if I don't have any means to meeting you, then it's problematic. So you need to think about who has the vital information for this. Yeah. And finally, the last thing is also important. Who's going to use this result? So why am I doing this assignment more than getting approved? So for this scenario, let's imagine someone who's receiving a report and is going to use that to make a decision. The newly gained information through testing is going to be used by someone. And you imagine who that is. It could be just a group who decides. It could be one of the people that you have in your group. The test. Yeah. Okay. A plan should also contain some kind of mitigation strategy for the risks. So I'm just going to test this one. And risks are things that can go bad during our plan. So if we know that that we have something that can affect our test process, perhaps we need to think about that when we're planning. So if you're unable to work during this, whatever, someone gets sick, how do we minimize the risk and the effect of this problem? Could be things like we really need access to internet during this task or whatever, or we need some specialized hardware to do this test thing, but we might not get that in time. We ordered that hardware from China or whatever, but we're not sure that we're going to get it in time. So that is a risk. We hope or aim that it's going to get here, but it could be a risk. Yes?
Should we assume that everyone in the team is motivated to do the assignment?
Yeah, I think that you can assume that all the members are motivated to do the assignment. Yes. Yeah. But it could be a risk if I'm saying that I've been feeling bad, or not bad, feeling ill. So I'm not sure that I'm going to be able to get to this week's meeting. That is a risk. I would say that this part of assignment 2 is pretty small, but if you're leading a bigger test effort, perhaps this can be something that you really need to think about. Uptime of the test system is something that perhaps not concerning the assignment 2, because you're probably starting the system on your own computers. But if we have a larger system, perhaps on specialized hardware and stuff like that, then we need to make sure that we have access to that during our testing. And it could be other people involved in this company thing that handles these things. Like, it's not super common, but it happens that when I give a lecture, something is broken somewhere. I think we had some tutoring during last course where a colleague of mine pulled a plug in some cabinet, so my network went down. And I mean, these are all risks, and you should plan for them. As in assignment 2, this is minimal. I mean, what can go wrong? Okay, focus on clarity. Plan is communication. Okay, so really there are 2 main groups of people that you're communicating with here. First, within the team. You're communicating within the team, and therefore you need efficient communication between you. But that is pretty easy if you can speak to each other. But it's also the matter of communicating between your team and the students who's going to peer review your plan. For this reason, I would be extra careful when I'm writing my plan. Make sure that it's readable. Make sure to use softwares for like correcting spelling mistakes. Make sure that if you put an image into it, that it's actually, you can look at the image and understand it, and that the image has a subtitle and everything that has about clarity in communication. You can assume that the person who is reading your plan is someone who's taken the same course, who has the same vocabulary. So use the vocabulary used in this course, in these lectures. Yeah, and I mean, step back and read your own plan before sending it in. If I were to read this and I don't know all the details, can I, from this plan and this test result and everything, understand what to do and what you've done? Does it look okay? My experience is that not taking the reader's perspective is the biggest problem here. That we just assume that everyone knows the things that I know, but I don't have no idea what computer you have and what issues you ran into and stuff like that. So communicate that. Sorry for not being able to repeat the question. So I'm going to try to do that the next time. So yeah. This one is, in what form should the result be presented? How do I make sure that the conclusion that I came up with as a tester is looking like that in the document? I mean, having lists of tests that fail or succeed, using perhaps green as color for succeeding a test and red as color for a failing test is pretty simple. To show that if this test case failed, it's this requirement that is problematic, that is not correctly implemented. So think about how is someone going to use this. So try to get traceability to the requirement. So you have a certain test case that failed, and that test case is connected to a requirement of which it's testing. So perhaps you show that requirement as broken also by put it in red, perhaps. Red and green is not always super good because people can be colorblind, but yeah. This is about the results of the test plan. So we could, I think in assignment 2, this is not super important. But in a bigger project, if you're doing something and you don't really have someone who's receiving your report and actually reading your report, and if you don't share your report, then nothing's going to be done about it. So we need to think about if we conduct testing and that testing fails, that leads to something, and we must facilitate that. Perhaps I'm actually printing the report or just emailing the report to the person who's supposed to take the decision. In projects, we really should think about beforehand on how should we act when we get a certain test result. And it could be very important also. You have this in assignment 2, a due date. So when is this effort going to be done? Who's going to get it on their desk when it's done? And I mean, in your case, it's pretty simple. You should upload the zip file before a certain time has passed, right? Okay, so that was sort of the test plan. And I don't know if you have seen requirements pyramid before, and I'm gonna focus on the screen. So the requirement pyramid, in the top, there are the ideas, the needs of the customer or the ones that want this software. So we have some kind of needs. It could be that I need a web shop in order to sell my products. It could be I need an administrative software to plan my work, or whatever needs we have. And these needs lead to something that we specify. So these are clouds because they are in someone's head or some people's head. And then we specify these needs as features in our program. It could be that, okay, we need to have a secure system. So we need a feature which is the authentication system within this. The authentication system makes sure that only the people who are supposed to get access to the system gets access, right? You know, log in. You have all the student IDs and passwords with those, and for every application you have this. So authentication system could be a feature. A feature itself are broken down by requirements engineering into use cases. Have you all read use cases? These short stories who's saying how is a customer's need fulfilled by the system? It's sort of this could be short stories, could be longer stories. And these use cases, I mean, one feature could result in many use cases. So for an authentication system, we could have a use case for logging in, and we could have another use case for logging out, and we could have a third use case for registering new users, and we can have more use cases. Different roles get something fulfilled by our system, some need fulfilled by our system. And these use cases resides in something that I would say is the specification of the system. And that is sort of what you get from the beginning in assignment 2. You get this specification, there are some use cases. There can be other things in this specification than use cases. It could be a supplementary specification. some requirements that are not really use cases, but are like the system should be user-friendly and stuff like that. The system should be responsive and things like that. Those use cases can be broken down into scenarios. If you've learned about use cases, you probably heard about the main success scenario. That is the path through a use case where things go as they should go. So for a logging into a system, the main success scenario could be perhaps that it starts when a user wants to log in. The system provides some means of logging in, perhaps some dialogue or whatever. And then the user provides the authentication, holds up their ID card or writes some username and password into the system. And then the system responds that you have now logged in. That is the main success scenario. But it could also be other scenarios. Perhaps the case where someone does not get logged in because they give the wrong kind of authentication into the system. So the wrong password or the wrong username or something like that. So that is a different scenario. So one use case can create several scenarios. And then from these scenarios over here, we can have from a single scenario, we can have different test cases. So the scenario was that someone got logged in, right? Using a correct password and a correct username existing, and these are in the database or whatever. We could create two different test cases, so to make sure that person A and person B both can log in to the system, right? So those are different test cases. Person A has one password and one username, and person B has another username and another password. Those are two different test cases for the same scenario. The same thing for the not getting logged in. You can have a single scenario that someone is providing information that is not correct and therefore they're not going to get logged in, but we have different test cases for this. So it could be that they are not giving the correct username, or they're not giving the correct password in at the same belonging to that username, or it could be that they're not providing any information. It could be that their account is no longer valid. It could be a lot of different things that are sort of the same scenario, but we create lots of different test cases. If we're creating something that has some, you've written test cases, at least in assignment 1 now. You know that we need to provide different inputs and see different outputs in order to get some sense of if it's working or not. So it's not that complicated. And that was sort of the things that I've already said. So if we have a use case, we can depict that as a state diagram. In this case, we have a starting state in the beginning. And I think the leftmost state transition is perhaps that we're, so if they're, okay. Here's perhaps the main success scenario, perhaps the rightmost is some other scenario, and we can also have these loops back. So in order to get a good testing of a use case that looks like this, we need to cover different scenarios. And it's sort of the same thing as we were talking about code last time, that we want coverage of all the paths. So it could be that we want to go from the topmost to the leftmost, and that is one scenario. And then we have another test case for this scenario where we go down here and down here. And then in order to get path coverage, we also want to take this return path. We can think or use the same kind of coverage theory with loop coverage and stuff like that also, to make sure that if we have such a loop in the program, we're actually going several steps through that loop, perhaps 0 times and oh, like that. 0 times, 1 time, and many times through the loop to get loop coverage. So here we have an example. And the main scenario here is, the use case here is called authenticate user. And the main scenario is that it starts in 1. It starts when a user wants to authenticate. The system asks for username, password, and if the system should save their user credentials. That is point 2. And as you can see from point 2, there are 2 different possible ways from that state into number 3, which is user provides username and password, but also 1 to 3A, which is user wants the system to keep the user credentials for easier login. And the main success scenario goes from 1 to 3 and 4. And 4 was system authenticates the user and presents that authentication succeeded. And then we have these alternate scenarios where we go 1, 2, and then to 3A. And 3A is that the user wants the system to keep user credentials for easier login. So the system authenticates the user, as before, and presents that the authentication succeeded and that the user credentials were saved. But there's actually one alternative scenario from that also, where we go to 4A, which is when a user could not be authenticated because there's some trouble. And then we show the error message and we go back to step 2 in the main scenario. So in order to get this covered, I would create, at least 1, 2, 3, 4, 5, something like that, test cases. And actually, I've probably created more. So think about it. How many different test cases do you want here? Just take a look at the image and let's take like 15 minutes break. Okay, welcome back. This is software testing and the second part of the system testing lecture. And we were looking at use cases and finding different scenarios and different test cases through these. So I seem to have a problem with my internet connection, so I have a slight problem to see the Slack questions. No idea why, but that is the case. So if you have Slack questions or if there's any problem, I now have a nice student who is helping me with that. So you can continue to ask questions through Slack. Okay, so we have use case. We have learned that there are different ways for this use case. We call those scenarios. And we also create different test cases, sometimes more than one test case for a single scenario. It depends on the sort of coverage that we want. It depends on how wide this scenario is. In our case, perhaps we want the error message in 4A, which is user could not be authenticated. Perhaps we're looking for different error messages in 4A depending on the kind of problem that we had with logging in. So perhaps there is a different error message if we come from 3A to 4A than from 3 to 4A. Perhaps there are different error messages depending on the way that we fail to log in. And the same thing goes for number 4. So we want coverage over the scenarios, and we also want to, in some way, present this to the reader of our test plan in at least assignment 2. We want to show to that reader that we've done this analysis, and at least one way of doing so would be convincing to me would be to show these paths through these scenarios and perhaps have some kind of coverage graph that shows that we're actually path covered this one. So if we ask the question, do we fulfill the requirements or the requirements that we are looking for, then we want to be able to express that some way. And I'm going to show it on the next slide because I'm suggesting that you should create a test traceability matrix for your test. But really, it could be the thing that you want to show is that you covered the parts that you intend to test. So the things that we prioritized, or the things that we said we're going to test, and that we've covered that part. And yeah, we've already talked about the other part. So this is a test traceability matrix. So you can see in the top, we have use cases. So we have use case 1.1, 1.2, 1.3, 2.1, 2.2. And then we have use case 2.3.1, 2.3.2, 2.3.3. What they mean with these different numbers could be different things, but I'm thinking that perhaps use case 2.3.1 and use case 2.3.2 and use case 2.3.3 is perhaps different scenarios within that use case. So perhaps we're using these numbers in order to identify different paths. And then perhaps above this matrix, we show that 2.3.1 means this way through a different through a use case. On the rows instead are different test cases. And we can see that different test cases are covering different paths through the use cases, different scenarios. And we can see that since we have we're summing up the values up here and down here, we can see that different use cases are covered by at least one test case. And if you have, we can see that use case 1.1 is covered by test case 1.1.1 and 1.1.3 and 1.1.5. This doesn't really show us that all paths are covered. We need to do that separately. And yeah. But at least it gives us some kind of coverage over the requirements. So just create a matrix, put the requirements on one axis and your test cases on another axis, and then you can show that all requirements have at least one test. So I suggest you do this in assignment 2. So there are also requirements in the supplementary specification, perhaps usability requirements or whatever, and you do some kind of testing of those. And you can put these here also to show that you cover all the requirements. So on the right hand, you can see these are technical requirements and things like that. Yeah. Okay. This is also great as an image to show which part of the system that is broken, so that we can get traceability from a broken test case to a requirement that needs fixing or needs reconsidering. Okay. Next part is about so many different types of testing, it's ridiculous. So non-functional testing. So far we've talked about functional testing. We have some kind of functionality. We create a normal kind of test case with expected output, and then we get actual output, and then we compare these two with as an oracle, and perhaps we automate this. But there are all these different kinds of testing that are a bit separate from these. And this is called non-functional testing. It could be, for instance, that our product is compatible with the rest of our products in our suite. It could be that if we have some kind of rule set that we must follow, then we want to see that this product is compliant with that rule set. It could be that we need some kind of performance. This is a web server, so perhaps performance is important. We want to make sure that this web server can handle so and so many transactions at the same time. Yeah. We want to make sure that it's scalable. We want to make sure, we want to do security testing. We want to see that it's not easy to break into this system. We want to do some usability testing of the web server's user interfaces and stuff like that. And I mean, here is a huge opportunity for you to choose something that you think is fitting for assignment 2, and then you select, and then you learn how to do this, and then you report that in your test plan. I would say that this perhaps is like 10% of your effort in total, just to make sure that I want to give you the opportunity to try out something and perhaps try some tools for this. But the main effort in assignment 2 perhaps should not be this, right? And the reason for that is that perhaps other students who are going to peer review your thing is going to learn a little bit about this, but if they don't understand the process, if they've not used the tools, then this becomes the focus of your test plan. Perhaps they don't understand enough to be able to judge anything about it. Understand? So if you're doing this for your 10%, make sure that you are clear and that you really explain to these students who are reading your artifacts that how you did it, what tools you used, how it's working, how you do, show that you're doing good. Yeah. So I think there's a nice list, or at least there was, yeah, so there are different types of testing, and you can read about this and learn about this. It's, I mean, more or less up to you. Oops. So one of the tools that is quite common is Apache JMeter. Perhaps you've heard about it. It's a tool for testing web applications, and you can use this for assignment 2 if you want to, like to do load testing. And I think why is it always jumping over to another screen? Let's ignore that for now. I've not checked if these links are working, but here is a link to a test plan and a test report from UPDO. Assignment 2 is a bit special, so I wouldn't rely super much on template for the assignment, but I think you should take a look at this and take the best parts. So look at this and see if are they really telling the story that I want to tell, and am I getting through in a good way if I use it this way. If I follow this, then of course follow that template. But I mean, be mindful writer and think about the students who are supposed to read your stuff. So you don't include super much things from the template that is meaningless. That is sort of what I want. I want you to like write these artifacts for assignment 2 with the idea that someone else is going to read this and learn from this and understand what you've done. So don't hang up on getting a template, because they have other requirements. They have other things at stake than we do. So assignment 2, perhaps some of you have read most of this. So let's just step through the assignment and see what we find. So the first part is more or less a description of most of the things that I've already said. I want you to make care that you read this, these rules and these goals, and make sure the first part of this assignment you can do that in a group with 1 to 4 students, but the second part is individual. So you need to do that on your own. So the first part is that we have the software development company, the SDC, stupid name, has found a possible market niche for giving out a simple to deploy web server. SDC aims to redistribute this server on a wide range of Internet of Things to present information from sensors, etc. SDC wants an easy-to-deploy Java web server that can be deployed on many different devices and therefore can attract attention of a wide range of Internet of Things developers. Internet of Things developers want a minimal configuration as well as easy integration and adaptation of the web server. End customers want easy access and absolute security. The SDC management has found an open source abandonware software called My Web Server on GitHub. Fantastic. It's your job as an SDC employee to evaluate the current state of My Web Server. SDC needs to know if the abandoned software fulfills the requirements as stated in the requirement document. Your budget is 1 man week times the number of students. SDC management want a strategy, a plan, a test cases, as well as a test report. So I mean, this is all made up and just to get to frame your work a little bit. And I mean, if it's going to be Java, probably, yeah. So it should run on some Internet of Things stuff. This could be seen as problematic already. Running Java on your light bulb or your whatever is not that easy. But yeah, take it for what it is. It's just a school project. And you're given the requirements. So there is a document. The abandonware requirements also. So these are not the requirements of the SDC company. This is the requirements of the people who built this software. That is me, really. But so you can check this out, and you can see that there are supplementary specification. So requirement 1 is that the web server should be responsive under high load. So perhaps in order to cover that requirement, you need to start up the web server and run it under high load, right? In some way. Perhaps this is something that you could use the Apache JMeter for, but you could also use other softwares, or like write a piece of code yourself, or whatever that is calling this software. Yeah, so there are different requirements, and then the use cases come here. So you can see that they have a post condition, a main scenario, and alternate scenarios. So perhaps you want to like look at these, create these graphs, find different scenarios, create test cases, perhaps manual, perhaps automated, through this. You're also given the source code. And already when I look at the first readme.md, you can see that, oh, it's the documentation that's not that good. So all these discoveries that you make, I think that while you're like looking at these, you should make notes. Because documentation is really important. Perhaps if you want to continue to work on a project, then you want to have good documentation, and apparently perhaps there is documentation somewhere. I'm not going to. So there are tests apparently, and they seem to be, yeah, some folders with a couple of tests. Perhaps we should run these. Okay. So what you're supposed to do is to write a test strategy for the application, as we talked about. How are you going to fulfill this scenario? What stakeholders are there? There were somebody, the SDC management, the IoT developers, different people, right? And when you have your test plan, you should include manual test cases in this. So you need to create some manual test cases. And when you have your test plan, you should execute the test plan. Actually do the testing of the software, getting a result out of that, and report that result. And in the end, you should get different PDF files, and you zip them. You don't RAR them or anything, you zip them. And it should be a strategy document. It should be a test plan document. It should be a document with test cases, your manual test cases, and perhaps other test cases, and then a test report. And you should put those in the same zip file. Yeah, and there are different rules. So don't think it should be anonymous. So instead of writing Daniel, you should write test lead or scrum master or whatever. Yeah. Okay. Do we have any questions about this? Yes.
It says it in the important notes, but it may be good to mention it as well. All students need to upload the same document.
Yeah. So you create one zip file. Yeah, I should repeat that, sorry. So I just get a note here that I should repeat I should repeat what student says in the class so that you online student can follow. Thank you. So and what he said there was that this thing is really important. All students in the group should upload the exact same document, and that what I mean with that is the same zip file. Please make sure that if you update the document and resubmit, all students update it. So within this system, it's CS quiz, but it's the peer review system of CS Quiz. You upload a file before the deadline, and if you have worked as a group, you need to upload the same file. So one person creates this zip file and then send that to the other students so they can upload it also. Yeah, and you're not supposed to share this between groups. In the end, you're gonna, as an individual, get to look at other people's files, and then you review those. And that is task 2. You review this. And I think that looking at these requirements for the review is pretty essential in order to get good reviews of your own documents. So when you write your document, read this thing. Make sure that everything here is in there and is easy to find. So, for instance, does the test plan describe what requirements that should be tested? Perhaps we make sure that the requirements we are testing are actually explicitly said in our test document. And after the review phase, then you give feedback on the reviews. You go in, you read the reviews, you swallow a couple of times and try not to cry when people are bashing your work. You think about, was this good advice? Have they really read my test plan? Did they find the things? And then you try not to be too defensive, because hopefully, or the realization in 2016 was that most reviewers are actually trying to do a good job. Then some are better than others. But here you have an opportunity to give the reviewers a bit of feedback. And you can also notify that so that I can see that this was not a good review. And not only that they scored you bad, but you also tell what was wrong. So we can like settle that conflict. And this is pretty important, and I don't want like throwing dirt forward and back. I just want people to be truthful and do their best. And I've seen some really, really crappy reviews, perhaps like the 10-minute review where you almost doesn't even read what you're supposed to review, and then you write everything was good, and then you give high grade, and that is not what you want either. You want people to read your work and give you an impression on how good you did, right? You want them to explain to you what you could have done better. Yeah. So it's about communication. And please note that you're not really grading each other. I'm grading you. Yes.
How would you grade team members? Like if there's a product owner or a team lead or something else, how you will grade the roles if they all submit the same? Like you will, for product owner, you will grade only the product owner's part of this submitted zip file, or something else?
Okay, so I get the question that how do I grade a group of people if they have different roles in the project? So someone was the group leader and whatever. So the first part of the assignment, task 1, is the group effort. And everybody gets the same grade on that. So all members of the group get the same grade on task 1. As reviewer, you are working on your own, doing individual reviews. So here your grade may be different from the other people of your group. And I think that it's 25% of the end grade of this course that is given as a group, and then 25% as individuals. If it should be, and let's hope not, that your group is not really working. If it's not really working, then let's split it up and do some individual work. But let's hope that does not occur. And I mean, you can contact me if you really run into problems. Yes. Okay, thank you very much. I think that is all for today, unless you have questions. Are there any questions? No. No? Okay, thank you very much.